Hi everybody, for today's video we're going to be running through how to use the LibGSM Code Generator to generate code for your project. We're specifically going to be using the SMS receive module, and as a quick note, the SMS receive module is completely free to use, so you do not need a license to go along with this video and follow what we're doing. The hardware that we're going to be using for this video is going to be the STM411, specifically the development board, commonly known as the black pill. And for the GSM modem, we're going to be using an LTE modem. The development board we're using is made by Electro, and the specific modem on it is the Subcom A7670E. And I will later show a video as well of the connection between the devices. The first thing that we want to do is we want to set up our project. So you do not need to use the exact hardware we're using with regards to the GSM modem or the MCU for that matter. As long as you have a compatible C or C++ compiler, then you'll be able to use that. So off the top of my head, if you want to use STMcube32 IDE, or if you want to use ESP-IDF or the ESP32, or if you want to use Arduino or anything else that's compatible with C or C++, and any hardware that is compatible with that as well. For our project, we're going to be using the Arduino IDE. So the first thing you want to do is just start a project in Arduino IDE. So if you want to start a new project, you can just click File, New Sketch, and it'll start a new project. It's going to close the old window, and we can open this. We're then going to want to save this project. So we're going to say Save As, and we're going to take it to a folder I've made called Generate Code, and I'm going to name this SMS Read. You can call this whatever you would like, but SMS Read just fits the topic that we're going to be running through now. After this, what you want to do is use the LibGSM Code Generator to generate your code. So the Arduino IDE uses C++, and you can also include the Arduino project checkbox over here. If you'd like to know more about this, there's a previous video that just gives an introduction on how to use the code generator and what the code generator is, and that'll explain a little bit more about C and C++ and what this checkbox does. After that, you're going to want to set New Project, and you're going to direct to where you've just saved your Arduino project, and you're going to select that folder. After that, you'll see that that folder is selected. Apologies, you'll have to, every time you say new project, it will go back to its default. Include that. You're going to say SMS receive and check dependent modules. So you want to make sure if you want to use a module that you always click this check module dependencies to ensure that everything you need to use them is selected. After that, you can click generate code. And once you click that, you'll see your files have been generated up here. Here's your GSM manager and your circular buffer files. You don't need to use these circular buffer files, but there are functions in the GSM manager that use them, and you can optionally use those or make your own functions if you would like. From here, the first thing I like to do is make a main.h file. In the main.h file, we're going to start with the if not defined for the main.h. Then we're going to define it. We're also going to just do the endif now so that we don't forget about the endif. After that, we want to do our includes. So we're going to include hardware serial.h that we can use the serial interface on the STM board, and then we're going to include the Arduino.h file as well. From there, we're going to do the GPIO setup. With the GPIO setup, we're going to define our pins that we'll be using on the board. So that's going to be our power key, and I'm going to assign that to PB2, and then I'm going to define GSM stat, and I'm going to put that to PB1. On top of that, we want a UART connection as well. So with our UART, the serial monitor will automatically be on the USB serial, and then we want an additional serial connection that we're going to be using to communicate with our GSM modem, and we're going to call that GSM serial, and in my case that will be assigned to serial 1. Please confirm these pins and which serial connections you have available on your hardware so that you can interface with your GSM modem. If you only have one serial connection, then you'll have to sacrifice your serial monitor. With regards to the GPIO setup, it is possible that you might want to also use the reset functionality if your hardware has it. Our board does not have the reset pin on this GSM modem, but if you would like to use it, you can come into the LibGSM Code Generator, and in the power module, you can enable the reset GPIO. And if you do that, a function will be available in the GSM manager where you can also use that, and then you'll just need to assign the pin here as well. I just want to take a moment here to show you our setup quickly. So this is the Electro development board, our GSM modem. It's going to be the A7670E. This is the connection to our STM. That's going to be our TX, our RX, our power, and our ground. And this is our black bull. That's the STM32F411. So we've got our connections going around the back here. You can see this is the status pin, the green one, and then the orange wire is our power key that is connected to our STM32, and at the back is our antenna. To the right, we have power connected to our development board, and on the left-hand side, we have, that's just a connection, the USB connection to our laptop. The next thing we're going to do is go through to the GSM manager, and then from here we're going to start with the includes. So in our case, we want to include main.h that we've just made. We don't need to include the Arduino file again because we already have that in our main.h over here. It's important to note that any code that you write needs to be within the user code begin and user code end tags. If you do not, that code will be lost if you regenerate. So for example, if I say generate code now, this include main will stay. But if I write any code outside of that, and I then again run generate code, that code will be lost. So if you'd like to make any updates to this code that's outside of the code that's already available, you'll have to do it within these tags, otherwise the code will be overwritten. After that, we just have our buffers here. I'm not going to go into detail in this video how these buffers are set up or if I'm going to change the sizes. There will be a video made for that as well, explaining how you can change these values if you would like to change them. These are your instance variables that are used. This is what's used for the library instances for each of the modules. The next important function is going to be the GSM system time millisecond. In this case, all you need to do is set up a function. We've provided example code here that will return the present value of a 1 millisecond system timer. So for Arduino, you can use millis. This is also available for all the other C and C++ compatible compilers. There will be an equivalent function. I believe STM32 Cube IDE uses hol, get tick, or something similar to that. The next set of functions is going to be our debug output. These functions, I'm not going to go into depth with every line of code what it does. This code is provided when the code is generated. So you can go through this and look what it all does. And if you would like a better explanation of what everything does, then you can request it in the comments of the video, and then we'll break down exactly what these do. But they're all either related to the circular buffer or to functions available with the serial capability of the Arduino system. As you can see, there is example code also for the STM32 Cube IDE, and then there'll be more sections of code here. You can change this as long as it has the same functionality of what the code is currently doing in these functions, because these functions are used by the library. These three functions specifically for the debug output. The next two functions we're going to look at is going to be our GSM set power key and GSM read status. The GSM set power key will set the status or the value of the power key. So that's going to either put it high or low. And what you want to do here is just assign that to the pin that you have defined. So for us, that's GSM power key as we set up in main.h. You just want to ensure that that is toggling the correct pin. And then again here for the read status, you want to make sure that that is reading the correct pin. So for this GSM set power key function, this is effectively the same as a button press that is being connected to the power key of your GSM modem, and then the same is true for the status output from your GSM modem. This pin is just reading that value. Again, as stated, for the debug output, these next couple of functions are going to deal with setting up the serial communication and interpreting the TX and RX values that are being sent between the MCU and your GSM modem. So if you would like an explanation of what these functions do, a lot of them can be found in the Arduino documentation, and then the circular buffer are the files that we have provided. I'm going to uncomment all of the Arduino code that's available here. If you're using the STM32 IDE, you can uncomment this code or adapt this code depending on your need. Same for this function, the same for write complete, the same for GSM can read, and the same for GSM read. Alright, the next thing that you'll see is going to be the GSM read event handler. So the GSM read event handler, this function will be triggered whenever there's an event that needs to be output from the SMS read module. So as can be seen in the LibGSM Code Generator, if you go through to your SMS receive module here and you scroll down to event handler, it will tell you what possible events can be output. So in our switch statement here, you'll see the GSM SMS read event type read success. And that is the same that you will see if you look at the same section here in your LibGSM Code Generator. This then, the event type read success will have associated variables with it. Once we actually receive an SMS, I'll go through this and explain what each of these variables are and how they're associated with the output. For now, I'm going to uncomment the example code. Don't forget to uncomment this text and value variables here as well. This is just variables that's being used for the output over here. Again, as I said, I'll go through exactly what this code is and what it's doing when we receive an SMS. The next thing that you'll see here is your GSM Manager init functions. So this is the init functions for your library. All the code in this section will be auto-generated using the LibGSM Code Generator. If you'd like to go through this, you can. It's not necessary, but this is effectively just initializing everything that's required for the library. Over here, we have the GSM Manager poll routine. The poll routine is just polling all of the functions required in each of the modules. So that's just going to keep going through all of them continuously. You'll see this set up in the SMS read. It's important that this GSM Manager poll routine is called as often as possible. After that, you'll see there's some convenience functions at the bottom here. We're not going to use this in the example, but you're more than welcome to go through this and look up these functions in each of the documentations for their respective modules. You'll see each of them are labeled via their module, so power, basic comms, and network registration. A quick guide is just some small functions that allow you to get extra functionality or extra information from the module. So you can get the power status, set the power status, change durations of the power key press, so the on and off time press, you can change that according to your module if it's not working with the default values. Here's this if communication is established and if we've managed to register on the network. All right, from there we're going to head over to our .ino file. So this is our SMS read. This is effectively your main function. The first include that we're going to put in is going to be our main.h that we have just set up. Sorry, I've made a spelling mistake there. Include main.h, and then the next one is just going to be our GSM manager that we just went through, but the .h file. All right, that's all we're going to include. And then the next thing we're going to do is in our setup routine here for Arduino, we're going to set up our serial communication. So we're going to do our serial setup, which is going to be, sorry, I keep making spelling mistakes. It's going to be serial.begin, and then our baud rate we're going to use is going to be that. And then this line is not required, but I do prefer, especially if you want to look at the serial monitor output, that you just wait for the serial interface to be set up. So this just allows that serial channel to be done with its setup procedure before we proceed on in the code. I'm just going to copy and paste this to save a little bit of time here, but we're going to do exactly the same for our GSM serial. We're going to do it on the same baud rate, and we're going to wait for it to be done. So I do recommend that you do include this line, because you don't want the code to carry on before you've ensured that the serial line that is going to be connected to your GSM modem is complete being set up, because if the library starts running, it's going to immediately try and start communicating with that GSM modem, and if that serial line is not set up, nothing's going to happen on that line until it is set up. The next thing we're going to do is our GPIO setup. We're going to set the pen modes. So the first one is going to be our GSM power key. And then again, just to save some time, sorry, we want to set this as an output. To save some time, I'm going to copy and paste this line. And we're going to make this our status line, and our status line is an input we are reading. All right, from there, the next thing that we want to do is we want to do our initializations for our LibGSM libraries. We're going to do GSM manager, and then we are going to call our init function that I showed you in GSM manager.cpp. And just to keep the comments consistent, this is just going to be our LibGSM init. After that, we're going to do just a little startup message to notify us that startup has successfully completed. That way we know all our serial setup and our library initialization is done. So on our serial line that is connected to our serial monitor, we're going to write startup. And that way we know that we are done with our startup. The next thing that we need to do is just going to the loop. And in our loop, we're just going to include one function, and that is going to be our GSM manager poll. So that is our polling routine that I showed you. We want to call this function as often as possible, as I did state, and it should not be placed in an area where there are delays that are taking, for example, if you've set up a delay for 1 second and then this is influenced by that delay. From here, the next thing you want to do is just verify your build and see if there are any errors. Once the verify is done running, you'll see that there's no errors and that your project is built successfully. If you do have any errors here, again, just rerun through the video and make sure that you have gone through each of the steps correctly. Now, this next step might not be required for everybody. It is required for my setup. So I'm going to show it so that everyone can see in case they have a similar setup. But for my device, I have a direct interface with the GSM status line. So that is not an issue if your GSM status line works on the same voltage as your MCU. But in my case, my MCU is at 3.3 volts and my GSM modem is at 1.8 volts. So it is quite often that this would be the case, that your GSM modem and your MCU is not working on the same voltage level, but there's normally level shifters in between the two. In my case, this is not true, so I need to adapt for that. So what I've done is I've just used the ADC on my MCU to determine if I am above that 1.8 volt value. So I'm going to copy and paste code in for this. I won't explain it as well, but just to save some time, I'm just going to copy and paste this because this might not be required for everyone. So effectively, I'm just saying I do need an ADC pin, and I'm then assigning them to GPIOs. In my SMS read function, the .ino, over here again, you want to define those pins as inputs and outputs. So I will come here and I will define them as inputs and outputs. But if you would like, you can include this code and just exclude the define statement. So if you do that, then your code will be in here, but you won't have this pin mode included. So for example, if you uncommented this, then that code would not be used. Right, after that, the next thing that you want to do is go into your loop function and actually trigger the simulated ADC pin. So we're going to go into our loop function here, and before we actually poll, we're going to call that function. We're going to call simulate status pin, and the code for simulate status pin is as follows. So what this code does is it just reads my ADC status input. So my status line from my GSM modem is connected to pin PA7. If it is greater than a certain value, this value is dependent on your ADC. If you would like an explanation on how to get to this value, let us know. But it's effectively the voltage range of your MCU, so 0 to 3.3 volts, and then how many bits your ADC is, and then you can determine what the voltage is depending how many bits are set in that ADC. If we are above our value, then we are going to write our simulated status output to high, and if not, low. So effectively we're just setting up a fake status pin on our MCU that is talking to itself. So it's going to look, what is my status pin actual value? If it's above 1.8 volts, then turn on my simulated pin that will then go to my actual GSM status input that we assigned here. So there's a direct connection between my simulated output and my GSM status pin. Right, from there again, if you have included this code or needed this code, you can verify to make sure there's no errors. Then after you've built, again, you should have no errors, and we can go over to our serial monitor. At this point, I'm going to put my board into boot mode so that I can flash it with new code. Let's just do whatever is applicable for your case, and I'm going to flash it with code. Once you're done flashing your unit with code, you can go over to the serial monitor and you should see the startup message that we added into our setup routine over here. At this point now, you're ready to receive SMSs, and if I send an SMS from my cell phone with an SMS stating test, then that will come through on the screen over here. So that's all you need to set up receiving SMSs with the LibGSM library. It will then give you, like I said before, a startup message, and then I'll come through and explain this event handler now, as I stated I would. So from here, we can see this will follow the output. So whenever this event is triggered, we have read an SMS successfully, we're going to output that a text message has been received. All right. After that, we're going to put 2 new lines and we're going to output the message status. The message status, as we can see, is 0. I'll explain that now. We can see the message then was received from phone number, the message contents, the SMS data, epoch time zone offset. So to explain all of these values to you, we can see this is the cell phone number, the message contents were test, as I said, epoch time, this is now the UTC epoch time, and then the epoch time zone offset. So that's if you want to get it into whatever time zone this message was sent from. Just to relate that to the LibGSM Code Generator, we can see here the data that is associated with this event. So we can see there's some variable that, if you look below, you'll see that's an enum that's being used, and we can see what each of those enums mean. So all of these outputs here are self-explanatory, with message received and then from, it's a cell phone number, contents, that is a string, and so on and so forth. So the message status value here, though, is maybe a little bit vague because you might not know what that means. So message status of 0, if we come here, we can see it says GSM SMS read, SMS status receive unread. So that is our 0 case, our number 1 case, number 2, number 3, and number 4. And what this means is a message was received and it is unread. This should be the case for most, if not all, of the SMSs you receive using this library, because the library will delete any SMS after it's been read to ensure that the SIM card is not filled up with an endless amount of SMSs. All right, that's the end of this video in terms of how to set up and use the basic functionality of the read library. I will, however, though, continue on this video and just add a little more functionality to allow the user to see how they can add a bit more in terms of, I myself like a breathe LED on my MCU, so I can just see that the code is running to help with debug. And then I'm going to add a bit of functionality in terms of this event output to show you, if you receive an SMS that states something specific, how you can change how the MCU reacts to those messages instead of just outputting it to you. The first thing you want to do if you're going to add the LED functionality is that you're going to come over to your main.h window. And then in our main.h, we want to define a function that we can use to determine how much time has passed. So we want LED to flash at a certain rate, but we don't want to be using any delays that could affect our polling routine for the library. So we're going to call a function millisecond since, and we're going to pass x to it. What we want this function to do is to call millis and then minus that time from it so that we know how long it's been. Then additionally, what we want to do is define variables that we can use to keep track of the on and off time of an LED. So we're going to define some external variables here. These variables we want to be external because we want to access them from both the SMS read file as well as the GSM manager when we receive an SMS. So we're going to call these G for global and then U32 for U32 values, and then we're going to name it LED off time. And then I'm just going to copy this to save some time, and we're going to call this one LED on time. The next thing that we want to do is define some variables that we can use to drive the LED. This is not something that you have to do, it's just something that I like doing, especially in example code where we don't know what hardware the end user might have, but I'm going to do LED built-in on. I'll explain this now, and then I'm going to say low, and I'm going to copy and paste that, and I'm going to do LED off and high. So for my specific hardware, if I want LED to turn on, I need to drive that IO low. And if I want it to turn off, I need to drive that IO high. So you can change this depending on your hardware if you want it to be low or high. The next thing that we're going to do is we're going to go over to SMS read, and we're going to define default values for the variables that we defined here. So I'm quickly going to grab these just to save some time, and I'm going to define some default values. So default LED times. From here, I'm going to get rid of the extern keyword. We don't need those again. And then I'm going to assign this to 250 milliseconds. And I'm going to do the same here. So these will be on and off for 250 milliseconds each. After that, I'm going to go to the loop code that we had over here, and I'm going to write some code that will toggle these LEDs off and on. And effectively that's going to be an if statement, and in that if statement I'm going to set up a digital read. So I want to do digital read, and I'm going to read my LED built in. So this LED built in value, depending on what you're using, will be assigned to a pin automatically. So if you have the library installed for the STM on the Arduino IDE, then this will automatically be routed to the built-in LED on the development board. Alright, so now from there I want to see if my LED built-in on that I defined earlier. So if my digital read of the LED built in, if it is on and the time, which I made the function milliseconds since, if that time is greater, sorry, if the time since it turned on, so that's going to be LED toggle timestamp, which I will define now. If that LED toggle timestamp is greater than our LED on time that we've defined, which we did above, then we're going to want something to happen, which is going to be turn off in this case. This LED toggle, we have not defined a variable for that yet, so we're going to do that now. This is just a timestamp, so we're going to make this static so that it doesn't get reset every time we enter this loop. We're going to make that a UN32, and we're going to call that LED toggle timestamp, and we're going to set it to 0. So that's the first time this goes, it's going to set that to 0. It's going to indent this to keep within this function. So now if we've read our LED built in, it is on, and the time since it was last toggled is greater than the LED on time, we want it to turn off. So then we're going to digital write our LED built in, and we're going to make it LED built in off. So we are writing our LED into the off status, and then we want to redefine what this toggle stamp is, and we're going to make that what the time is now. So effectively, we've turned it off and we're defining a new timestamp so that we can confirm the next case, and that's going to be this else if. And again, that's going to be the same logic. If we read it, I'm just going to copy and paste this to save time. If we read our LED built in and it is off this time, and our timestamp that we've taken it is greater than the time it was supposed to be off, then we want to write it to be on. So we're going to digital write our LED built in, we're going to turn it on, and we're going to redefine this timestamp. If you now build this code, you should again get no errors. Sorry, you in fact will get errors because I've typed unit instead of uint. So I'm just going to correct that throughout the script quickly, and then that would be the case here as well. At this point now, if you rebuild it, you should not get any errors. Alright, perfect. Again, now we can flash our board with this code so that we can see our new, I call it breathe LED, but just an LED flashing to show that the code is running. So I'll put my board into boot mode so that I can flash it, which I will start now. So once your code is done, you should see that it is successfully uploaded and your LED should be toggling. I've noticed though that I did forget to define this as an output, the LED built-in pin, so that will in fact not be working at this moment. So you just want to define that as an output as well, and then your code should run perfectly from there. So if we then again put our code into bootloader and rerun the upload, then it should be working from there. So we're going to put our device into bootloader. This might not be the exact same steps for you, but just do what is relevant for you before uploading. Alright, now at this point, you will see there will also be a breathe LED on your device that is flashing on and off. I will show a video of what our hardware looks like as well while doing this. So from our setup over here, you will see now on the MCU, this LED, the built-in LED, is now flashing on and off with 250 milliseconds on and 250 milliseconds off. Alright, the next step now is if you would like to change what happens when you receive an SMS, just to see how you can read an input and then change what happens depending on that input. So the next step that we're going to do now is go through to our event handler code, that we spoke about earlier, and in the event handler, we are going to now adapt this code so that we can change what happens depending on an SMS that is received. So the first thing I'm going to do here is I'm going to add a helper function. So this helper function is just going to be something that converts any message we receive to lowercase so that it's easier to interpret, so that depending if you send an uppercase or lowercase message, it will be interpreted the same way. So I'm going to copy and paste this in. You're more than welcome to pause the video and just copy this quickly, but this is just a function that's going to lowercase whatever string they sent to it. All right. The next thing we want to do is scroll down in our case over here. So when we successfully read a message, what we're going to want to do is, again, I'm going to copy a little section in here. So underneath this debug right, come and copy and paste this in, and then I'm just going to ensure that it's at the same level as the rest of the code, and then I'm going to explain what this does. So, sorry, I'm just going to scroll down so that you can see and start typing and pause the video here if you'd like to include this code as well in yours. But what this does effectively is copies the SMS data into the text variable. It then sends it to the lowercase function that we just put on top here. It lowercases everything, and then from there it looks at that text. If the word on is received, then it's going to change the flashing routine of our, what I refer to as a breathe LED, to 500 milliseconds off, 1500 milliseconds on, and then the opposite way around if the word off is received. Then if any other message is received, it's going to be 1 second on and 1 second off. I'm going to change this so that it just goes back to the default, so that in this video it's easy to differentiate between what is happening. At this point, then you can build the file again or verify it to confirm that everything is correct. Right, once you've verified that the code is correct, you can then get your device ready to be flashed with the latest code. So in my case, I'll put it in boot mode, and then I will upload the newest code. I want to clear the serial monitor. Right, once this upload is done, you then get your startup message and your device should be in its default breathe state. If now you decide that you want to send a message to this device, let's start with on, for example. If I now send on, I will get a message saying on, and you should notice that the flashing routine of your breathe LED has changed. I will now go over to a video on our system to show you what this will look like. So on our hardware here, you'll see now that that is no longer blinking at 250 milliseconds on and off, but rather 500 milliseconds off and 1500 milliseconds on. This then we can repeat. If we would like to now, instead of sending on, we can send off. This is obviously just an example of what you can do. You can trigger anything that you'd like with your MCU. But if we now send off and we receive off, then if we go over again to my hardware, I can show you that that flashing has now inverted. So it'll now be off for 1.5 seconds and on for 500 milliseconds. And then if we would like to effectively get it back to default, what we can do is just send a message with anything. So if we send anything else, then that will take it back to its original 250 milliseconds. So I sent a message saying anything, and if we now go back to our hardware, you will see that that LED flashing routine has gone back to 250 milliseconds on, 250 milliseconds off. Alright, that's where I'm going to be ending this video. That's just a quick demonstration of what can be achieved with this library, quick to set up, and there's a lot of documentation as well that's provided in the code generator to help you step through anything that is needed to use all of the modules. It's important to note, even if you don't own the license, you can go through all of this and read up on them and what they do to understand how to use the other modules as well. If there's any questions or anything like that, please let us know. Either contact us via the website, or you can leave a comment down below, and then we will be happy to answer you with any of those questions. Thanks very much.